Again, good afternoon, everybody. I'm pleased to be here and thank Devalina Ramanan and Joel Powell for the opportunity to talk to you today in this inaugural webinar on diverging pathways for natural gas. So this is under the subject matter of carbon management and the topic about lowering the carbon intensity of natural gas. And this presentation and the associated white paper are the result of research done at Bauer College, as well as a symposium we had this spring on the subject. And you can find the white paper on the UH Energy website as well. This topic is important because natural gas demand is expected to continue to grow. Mainly in the developing countries, driven by their growing energy needs, as well as a desire to replace higher carbon, more polluting forms of energy, particularly coal. So it's an important topic. I want to talk a little bit about kind of current gas markets. Natural gas traditionally been marketed as a commodity. Something that is standardized and whose price is driven basically by supply-demand fundamentals. In the cash market, natural gas is valued by location and delivery date, either in the cash market or in organized futures exchanges. Some gas is sold under term contracts that have a specific duration, usually a price index. And the price, in addition to the standards of location and time, the prices can reflect the choice of pricing index, the reliability of supplier offtake agreements, and some of these other factors in the cases of gas being marketed under term contracts. The three most developed demand centers we have are Western Europe, North America, and North Asia. These are places that have significant demand as well as established pipeline networks. Natural gas was deregulated in the United States in the late 1980s, and that led to the development of numerous hubs around the United States, as well as the development in 1990 of the Henry Hub gas futures contract on NYMEX. In Europe, there are two main trading hubs, one in UK and one in Netherlands. And recently, there has been an establishment of some limited trading markets for liquefied natural gas in North Asia. So that's the current situation. As a low carbon fuel, the future is bright for natural gas. However, the natural gas supply chain has significant greenhouse gas emissions that need to be addressed. If you look at just the combustion from the fuel, natural gas has much lower CO2 intensity than oil products or coal. The problem with natural gas in terms of greenhouse gas emissions is that there's significant emissions from the natural gas supply chain in large producing countries like the US. As you can see in this chart over here on the left, the natural gas supply chain production all the way through to consumption is responsible for about 8% of greenhouse gas emissions, which are made up of carbon dioxide, but also significant methane emissions. And the carbon dioxide emissions come from the fuel use in the production and transportation of natural gas, whereas emissions come from the production and transportation facilities, leakages, flaring, things like that. So a promising future for natural gas as a relatively low carbon fuel, but we need to address greenhouse gas emissions. So based on that and these concerns about the life cycle greenhouse gas emissions from natural gas, we believe that the different carbon intensities of different natural gas sources are likely to result in diverging paths for natural gas market. And listed here are some of the drivers for that conclusion, and I'll talk about each of those individually. So first of all, we can distinguish between different sources of fossil natural gas based on their different levels of carbon intensity. On this chart, you can see the top half is land-based production and transportation of natural gas from the main gas-producing regions in the United States. And then the bottom two pieces are the production and transmission of natural gas to a liquefaction plant, and then the liquefaction and shipment of natural gas to Europe and to Asia. And so as you can see here, there are differences in the greenhouse gas emissions intensity of these different pathways. So the possibility exists to differentiate even amongst fossil natural gas value chains. If you look at this at a global basis, not shown here on the chart, if you look at the largest 50 gas fields in the world, they range by about a factor of 5 in terms of carbon intensity. If you look at LNG imports in an importing area like Europe that has multiple sources of LNG, the carbon intensity of the highest carbon intensity of the main LNG imports into Europe from Algeria has about 50% more life cycle greenhouse gas emissions than the supply from the lowest carbon intensity resource, and that is from Qatar. So they're just on the basis of fossil fuels, there's an opportunity to differentiate just based on the production and then associated supply chains. Fortunately, there are opportunities to reduce emissions along all those fossil fuel value chains. And you can see here, this chart kind of splits into the two different greenhouse gases that we're trying to abate in the natural gas supply network: methane abatement on the left and CO2 abatement on the right. Methane emissions come from the use of natural gas in pneumatic controllers, fugitive emissions, and other things. But there are abatement mechanisms that can significantly reduce the cost of these fossil value chains. Similarly, in terms of CO2 abatement, that's mainly focused on the fuel use along the value chain, whether it's lease and plant fuel or pipeline fuel, and obviously controlling flaring as well. So the different fossil gas value chains have different emissions as they stand today, but there's opportunities to reduce the carbon intensity of all of those. A second pathway, in addition to reducing the cost, the intensity of fossil gas chains, are producing what's called renewable natural gas. Renewable natural gas is a purified form of biogas that is produced from waste streams. Renewable natural gas is essentially a drop-in fuel, and there are over 400 facilities producing renewable natural gas in the US today. You can see here in the row on carbon intensity, it is possible to have significantly lower greenhouse gas emissions from the different renewable natural gas pathways, and in some cases, because of the avoided emissions of methane, in fact, have negative emission gas. Of course, the challenge in the bottom row is the supply cost. As you can see here, with fossil gas in the US, anywhere from $3 to $5, although it hasn't been that high recently, these other pathways are significantly more costly. So you might ask yourself, well, what was the driver for those 400 plants to be built in the United States? And the answer to that is that the main driver has been the low carbon fuel standard in the state of California for credits for introducing low carbon transportation fuels into the California market. And when you look at the economics of these current plants, over 90% of the revenue comes from the credit from the state of California rather than from the actual revenue of the gas itself. So hence, an industry that's been spurred to be developed based primarily on credits associated with one natural gas market. The problem is that the California market for natural gas in transportation is very limited. The other challenge is that even if we were to capture and process all of the waste gas from landfills, agricultural, food, and wastewater, as shown here in the third row, it would not amount to a hugely significant portion of our natural gas supply, probably somewhere on the order of a couple percent. So an opportunity to introduce lower carbon intensity natural gas, another pathway, but not likely to be one that's going to be very dominant in the US supply situation for natural gas. A third option is synthetic methane. We can make synthetic methane from captured CO2 and low carbon hydrogen. The life cycle emissions of that synthetic methane depends primarily on the source of the captured CO2. If we capture CO2 and use that along with low carbon hydrogen from high purity sources, so think about like an ethanol plant exhaust or ammonia or natural gas plant, that can be a significant reduction compared to fossil gas, perhaps on the order of 60–70% reduction. Again, the problem here is life cycle cost. The current estimated cost of synthetic natural gas, assuming some fairly optimistic prices for the inputs of electricity and the hydrogen, are estimated to be about 10 times the current fossil gas price. However, synthetic natural gas is covered by some of the US tax credits, 45V tax credits that have been introduced for hydrogen that could reduce those costs somewhat. But again, likely to be a very high cost source of natural gas. A fourth option is to reduce the carbon intensity of natural gas is to blend in hydrogen. This chart just shows a theoretical calculation of the total life cycle emissions for different blends of hydrogen and natural gas. As you can see here, if you could blend significant portions of hydrogen into the natural gas, you could get a significant reduction in the life cycle emissions. Unfortunately, there are a lot of challenges associated with doing that. Concerns about material degradation, corrosion of pipelines, operational requirements, compression, potential for fugitive emissions and leaking. As a result, the practical limit for blending of hydrogen in existing natural gas grids is probably somewhere on the order of about 10%. Now, there is one gas grid in the United States which does blend higher levels of hydrogen, and that's actually the Hawaii gas system on the island of Oahu, where the gas supply is a mix of synthetic natural gas that's actually made from naphtha, from gasoline, a gasoline type cut, as well as imported LNG and imported renewable natural gas. And the reason why that system is tolerant of more hydrogen than most is that it was originally a town gas system, where the town gas had a much higher proportion of hydrogen. So the system was designed to be able to handle a higher level of hydrogen blended, which unfortunately is not the case for most existing large gas systems. So, 4 options to reduce the carbon intensity of natural gas. First of all, by addressing the emissions of existing fossil natural gas, trying to abate the methane and the carbon emissions that exist. Second, renewable natural gas. Third, synthetic methane. And then lastly, hydrogen blending. So 4 options that could contribute to reducing the carbon intensity of our natural gas. So the question is there a market for that? One of the reasons that supports the argument that there is going to be a market has to do with international trade. The international trade in natural gas is growing, and it's shifting from pipeline gas to LNG trade, which in theory allows more customer choice. You can, if you are an importer of natural gas, you can, in theory, import from a variety of regions if you're importing LNG, much more choice than if you are connected by, possibly only one importing pipeline. And natural gas demand is expected to grow in almost any scenario, at least through 2040. The demand growth is likely to be in the developing countries in Asia and the Middle East. Production growth is likely to be in North America and the Middle East. And then again, we're going to have this shift in the trade of natural gas going from about 63% of all internationally traded gas in the form of LNG today to about 72%. So effectively, gas pipeline trade is going to be flat. All the growth in international trade in gas is expected to be for LNG. And a lot of that has to do with the fact that Russia, as the world's largest pipeline exporter of natural gas, is being forced to reduce its exports to Europe and redirect them to China. So that this growth in international trade is one argument that suggests that customers will be able to use the carbon intensity of the LNG that they buy as a differentiating criteria for where they purchase gas from. We're seeing a little bit of this today. Japan has imported about 30 cargoes over the last 3 or 4 years of what's called carbon neutral LNG. Now, that's not LNG that had its carbon intensity reduced by any of the methods that we've just talked about. It's regular LNG with purchased carbon offsets. So it's just demonstrating an interest in lower carbon intensity natural gas, but it's not actually low carbon natural gas. It's at least so far, it's been deemed to be carbon neutral LNG by buying offsetting credits for it. Okay, so there are government policies in place. Another reason that suggests that the natural gas market's paths will diverge. There are a lot of different policies that can be deployed, and we've seen most of these already in some places or another. They can include, obviously, pricing, taxation, subsidies, regulations, including bans, and an interesting one, which particularly supports the differentiation of natural gas, which is required information in terms of required disclosures or labeling. Sorry, I went one too far there. The most aggressive policies have been implemented so far in Europe. The CO2 emissions trading system, which is already in place, that controls the CO2 emitted by end users, which kind of sets a benchmark. And the EU treats methane differently than other gases, and they're currently working on a law that would have some extraterritorial impact on methane reductions. And like the US, renewable natural gas and synthetic methane also going to get support from their renewable energy directives. In the US, we have the Inflation Reduction Act. Authorized the EPA to implement methane's emission and waste reduction incentives for the natural gas and oil supply chains. The EPA has proposed collecting an annual waste charge on methane emissions. This has not been enacted yet. But there are clearly things underway in the US that will give the natural gas supply chains incentives to reduce emissions of both CO2 and methane. There's no major initiatives to put any kind of restraints or import taxes on gas imports to Europe, probably because their primary concern at the moment is having natural gas available to replace the use of coal. They also have concerns, being large importers of natural gas, about supply security. But eventually, we expect to see some government policies in the North Asian countries, Japan, Korea, that could be reinforcing a choice for lower emission natural gas. So there are obviously a lot of challenges associated with developing these differentiated gas markets. Obviously, all the investment that we talked about, potential changes in government policy. But the changes that are required are manageable. One of the first is standardization. As preferences for lower carbon intensity natural gas expand, we're going to need some standardization of what we mean by low carbon intensity natural gas, how it's measured, how it's determined. There are a lot of voluntary declaration systems out there. There are a lot of standards being talked about. Europe, looking at the carbon border adjustment mechanism and potentially applying that down the road to LNG imports. So standardization, a big challenge. Sell side declarations, having natural gas when it's sold, have specific sell declarations by the seller as to the carbon intensity of natural gas. We talked about buy side incentives from governments or other places. A movement over time to move to measurement as opposed to estimation. As this market gets bigger, we're going to need standard ways to actually measure the carbon intensity along the value chains, so that every cargo of natural gas is actually measured, as opposed to just a general assessment of the emissions along that particular value chain. And then ultimately, demand for independent certification. This has already started. While the standards there are different certification organizations and different standards, but quite a bit of gas is already certified, in quotes, by one agency or another. Obviously, a need to greatly expand that as well. But again, these are all challenges that are ultimately manageable. So finally, in conclusion, again, we believe that the different intensities of natural gas, of the different sources of natural gas, whether that's fossil natural gas or others, allow for a diverging paths for markets for different forms of natural gas, and different pathways for the markets to develop. The opportunities we talked about to differentiate fossil gas supplies that are the basis of our system today, small opportunities for bringing renewable natural gas, synthetic methane, or even hydrogen blending into the system to lower the carbon intensity. The shift in natural gas trade, which is growing from pipeline gas to LNG, would allow more choice, would allow buyers, importers of LNG more choice. And one of the criteria they could take into account is the carbon intensity that comes from the different sources that they're using. There are lots of government policy options which are available to reduce emissions of natural gas along the supply chain. And the challenges from a marketing perspective of getting some transparency in the markets are manageable in terms of standardization, certification, declarations, and that. So that's in summary are the results of our analysis. I'd be happy to take questions. I suspect there's probably some in the chat.
Yes, there are two comments, and there is one question that came to me directly, probably as a mistake, but I will probably start with the comments. So Oscar, if
Yeah,
you want to go ahead and unmute yourself and elaborate a little bit on your comments there.
Yeah, just adding really to what Professor Bean was saying, that in one other suggestion for slide 7 and is adding vapor recovery units to oil facilities, and getting rid of open top tanks, which are used a lot, especially during completion operations and whatnot. And that's just getting rid of methane going to atmosphere and putting it back into the pipe. So that's
absolutely, yes. Good. That's a good point. We were kind of summarizing and thinking, primarily about the natural gas value chain itself, but absolutely in terms of oil production facilities, definitely.
yeah. And
Good
then the
point.
other thing I was going to comment on is in carbon neutral LNG.
Mhm.
The countries have started to differentiate between LNG cargo. So, like, what is the carbon intensity of the regional natural gas that was used to make that LNG, so
Right.
that you can so that the carbon offsets are different prices, basically, right?
Mhm.
And then that kind of rewards people for producing more responsibly the 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 gas without the like the flaring and the venting and with the electric actuators and all the good stuff that you mentioned there.
Absolutely, yeah. And if you look at the paper, the chart is not in the presentation. I was trying to keep it relatively brief. There is an example of the different carbon intensities of LNG going into Germany, for example. And they're quite different, even on the basis of just estimation, never mind measuring actual measurements. And so there is already enough data for buyers, for importers to start differentiating. You're absolutely right. Debolina, are there other questions? I'm sure.
Yes, there is one other question that came directly to me, and this was asked by Sri Vikas. It says, has there been any standardization done on renewable natural gas for the natural gas supply chain? Is there a certification agency for RNG?
I believe that at least one of the certification companies does cover renewable natural gas, but I need to double check that.
And if I just wanted to put this out here is that we do want to have more engaged discussions regarding any of these topics that we are going to have webinars on. So if anybody else in the audience has an answer, please go ahead and raise your hand and we'll be able to have this in a discussion mode. Also, if you have any questions and would like to directly ask, you may raise your hand or just unmute yourself and ask the question. So um, those were the questions in the chat, but we will wait for a few more questions. So Bill has a question in the chat. Bill, why don't you go ahead and unmute yourself? Yeah.
Hi guys, can you hear me?
Yes.
Yes. Uh-huh.
Super, yeah. Great presentation. Thank you very much. Yeah, so my question, which people can read in the chat, goes like this. Over the last 10 years, the US has emerged as a major LNG exporter, especially to Europe. And I imagine that that's a consequence of many things, including geopolitics, but also engineering, fracking, etc. What do you see looking ahead over the next 10 years for US LNG exports?
Well, I think certainly expect them to continue to grow. Let me just I'm gonna go back to I had one chart that had LNG imports and exports. So if you can see from an export perspective, we actually see, this was an Oxford Institute of Energy Studies, but I think it's pretty representative of other kind of standard business as usual kind of scenarios. And they project a significant growth, actually over a doubling of LNG exports from North America. Now that's all exports, so that some of that could be going to Asia as well. But I think that's pretty consistent with most views that the U.S. has got, low cost, obviously low cost LNG. And then the real question would be, if you get back to, and I don't have a chart which compares U.S. exported LNG uh, to Europe from other sources, but I'm just looking here. In the paper, there is some information on that as well that isn't in here. In fact, I think if I remember correctly, if you look at the chart, apologize, I'm just looking through the paper here real quick. The chart that had the yes, carbon intensity of German LNG exports, which is on page 8 of the paper. If you look at it, you actually see that according to this calculation by a German research firm, the U.S. average carbon intensity of U.S. Exports to Germany is actually second highest only to Algeria. That's a current state. And then we had the separate, you can see the differences in the different US regions that I showed that chart earlier, this one. So you could see down there at the bottom shipping to Asia. I don't know, I assume they just kind of averaged it all to come up with that number, but clearly the US has the economic situation in terms of producing natural gas and exporting it well in hand. They'll just need to be looking more carefully at what the competitive carbon intensity is to the big markets in Europe and in Asia, North Asia, I think.
Thank you. Very helpful.
Other questions, comments?
Thank you, Bill. And Greg, I have a question. So over the last decade, we had seen a lot of, as we saw the growth in the shale gas and fracking in the US, we also saw some of the natural gas liquids being converted into products. Also, natural gas was seen as an LNG as a final product, but also other products like hydrogen is being sought from natural gas. So what do you think about the end product being LNG versus any other products that come from the natural gas and associated supply chains? How does that play in versus like LNG versus other products from natural gas?
Okay. Yeah, I mean, I can give you some thoughts. We didn't cover that directly in this work, but based on, other work we've done, I mean, we expect, pretty significant growth in hydrogen, in low carbon hydrogen, and some of that, depending on which analysis you look at, most people think that, somewhere between a third and a half of global hydrogen, low carbon hydrogen production could come from natural gas with carbon capture. And I would say that, that the market for global hydrogen and international trade in hydrogen is expected to grow fairly significantly. Would be hydrogen and the derivatives of hydrogen, so not just liquefied or compressed hydrogen, but also ammonia, maybe methanol even as well, are expected to be pretty significant in terms of ways of having international trade, particularly from places that have, very good wind and solar resources that can produce low carbon hydrogen quite cheaply, and then send that to countries, to places probably in Europe and a few places in Asia that are going to have more costly solar and renewable and would be better off importing the low carbon hydrogen. So that, in terms of, I think that is going to be, a factor going forward, particularly perhaps, not so much in the next 5 or 10 years, but maybe looking out a little more on the 2040, 2050 timeframe. But I think the opportunity for natural gas, to maximize, the demand for natural gas and extend the growth in natural gas demand for as long as possible, is to, address this carbon intensity, make it transparent, and that should help with maintaining the market for natural gas. I can't really comment out too much else on if you're talking about natural gas liquids. I suspect that at some point, if natural gas liquids are being exported to produce petrochemicals in places that the carbon intensity of those products derived from natural gas would probably be, people would want to know something about that as well. I haven't seen that personally yet, but I suspect that's probably going to be true. I think pretty much all of the fuels going forward, natural gas just being one, there is going to be an increased interest in people understanding what the life cycle emissions were.
Absolutely. And thank you so much. So we do not have any more questions in the chat, but I do want to thank you and take this opportunity for being our inaugural speaker. Greg, I reached out to Greg because we did want to set the stage with what we will have in terms of the breadth of the energy transition, and natural gas happens to be one of those key transition energy resources. So again, when we think about energy transition, we know that we cannot go overnight from the fossil resources to our renewable resources. So there has to be a pathway, there has to be a transition. And that's why we start this webinar series with the natural gas and gas as the immediate future energy source. So thank you very much, Greg. And
Sure.
As a outcome of this, we will be sharing your webinar video, as well as the link to the recently published white paper on our website. So everyone will have access to that information and the basis of this talk today.
Yeah, and I would encourage everybody that's on the call now to download the white paper, because there's a lot more detail in the white paper than I was able to put in the presentation. And also, if upon doing that, or in thinking about just the presentation here, if you have any questions or comments, you can find my email easy enough. Just send me an email. I'd be very happy to engage in more discussion around this topic.
Absolutely.